If you find this question in any interview or in any exam, you are definitely going to find it difficult to solve. But just in this video, I'm actually going to show you the simple way to solve this. And then by the end of the video, you should have known how to solve questions like this. Of course, it looks hard, but then with the method we are going to use to solve it, you can see that it is actually going to be pretty much simple. Okay, so what we have is minus 5 raised to power x is equal to 5. So we want to find out the value of x that is actually going to satisfy it. Is, of course, if you are new to our channel, do what to hit the like button, subscribe to our channel even as we proceed in the video. So what I'm going to do is actually to simplify this minus 5, so I can actually write it as minus 1 multiplied by 5 all raised to power x is equal to 5. And of course, you know that if you have, let's say, a multiplied by b all raised to power, let's say, c, you can actually write this as a power c and then multiply by b power c. Okay, so if I utilize this property over here, this stuff is actually going to change to minus 1 raised to power x and then multiply by 5 raised to power x is equal to 5. Okay, so I am actually going to be making some substitution. There is no real value substitution for this minus 1, so I'm actually going to be using this expression because, of course, exponential of I pi is the same as minus 1. Okay, so this is actually what I'm going to use to replace minus 1 over here. So if I do that, in place of minus 1, I'm going to be having exponential I pi. Okay, then I'll multiply by this x multiply by 5 raised to power x is equal to 5. So moving on here, the next thing I want to do is actually to bring down this exponent right here. So, and I can actually do that by taking the natural log of both sides. So I will have natural log of exponential of I pi x multiplied by 5 power x is equal to the natural log of 5. Okay, so moving on, I'm actually going to be using one of the properties of logarithm, which of course see that if we have log a multiplied by b, you can actually expand this as log a and then plus log b. So when you have a multiplication, you expand it as plus. So that being said, this stuff is actually going to change to natural log of exponential of I pi x and then plus the natural log of 5 or x, and all of these will still be equal to the natural log of 5. Okay, so moving on, what I'm going to be having at this point is the natural log of exponential, let me just rewrite, plus the natural log of 5 for x is equal to the natural log of 5. So I'm actually also going to be utilizing another rule of logarithm, which says that if you have a log a power b, you can actually use this power here to multiply the log of a. Okay, so if I do that over here, this I pi x is actually going to come down to multiply the natural log of exponential, and then still using that here, x will come down to multiply the natural log of 5, and this will still be equal to the natural log of 5. Natural log of exponential is equal to 1. 1 times I pi x will be the same as I pi x, and then plus x multiplied by the natural log of 5 is equal to the natural log of 5. So what I'm going to do next is actually to factor out x here, because we are looking for the value of x. So I'm going to factor that out, and on this side I will have I pi plus this side I will have natural log of 5, and this will still be equal to the natural log of 5. I will divide through by I pi plus natural log 5. Okay, I pi plus the natural log of 5. This is actually going to cancel this, and eventually x will be equal to natural log of 5 divided by I pi plus the natural log of 5. And obviously this is actually going to be the value that of x that will satisfy the problem we are solving. So this is how you can actually solve this. And so what you're actually going to do is you can actually go ahead to compute natural log of 5 and then put it right here, which is basically going to be giving you a real value. Okay, so but the whole value of x is actually going to be complex number. So you can see basically here that x is an element of complex numbers because of the presence of this imaginary number over here. But this of course will give you a real number. So if you compute all of them and put right here, you're also going to be having a complex number. So this is the value of x. And then let me have your thoughts in the comment section. Like this video and then subscribe to our channel for more updates, and I'm going to see you guys in my next video. Bye.